So in section 4.5, we're going to kind of put everything we've learned together about logarithms, okay? And it's going to also connect some exponentials. So what's going to happen is we are going to be given equations. Sometimes these equations are going to be exponential, meaning the variable that we're trying to solve for is in the exponent. Some of the equations they're going to give us are going to be log equations, meaning the variable we're going to be looking for is in the log position, generally the argument position. Like this x plus 1, x is in the argument position. We have never solved these kind of equations before. How in the world are we going to figure out what number to put in for x to make these equations come true? Okay? And it's going to make use of some of these log properties and the relationship between logs and exponentials. Okay? Remember, logs and exponentials are different ways of saying the same thing. If you've got x equals a to the y, that's the same thing as saying log base a of x equals y. And we're going to use that to our advantage. Okay? If we get to a point with an exponential equation that we can't figure out what x is, perhaps converting to a log will help us. Remember, the whole point of a log is to get the exponent by itself. So that will get x out of the exponent and on the main line so that you can finish solving. So when you're solving exponential equations, we will frequently convert to logs. When we get over to the log equations later, we will frequently convert to exponentials. Okay? So that's that connection there and how we use those. These properties will come into play. Okay? And we'll see some of that a little bit later on. Okay? All right. As we mentioned, exponential equations are equations where the variable is in the exponent. So if I had 2 to the x equals 16, that's an exponential equation. I'm trying to figure out what x is. Now, sometimes we know. I just know that 2 to the 4th power is 16, so I'm going to go, oh, x is 4. Great. But if I didn't know that x was 4, I could convert this to a log. I could say, oh, log base 2 of 16 equals x. And I can type log base 2 of 16 in my calculator. If I've got an 84, I go to math, log base 2 of 16, and it says, oh, that's 4. If you don't have an 84, if you're using an 83, you would type log 16 divided by log 2. You would use your change of base. And it will still tell you that the answer is 4. Okay? So exponential equations, your variable is in the exponent position. If you can't solve it on your own, you can convert it to a log and let your calculator help you. Log equations means your variable is in the log portion, generally the argument. So maybe I have log base 2 of x equals 3. Okay, well, wonder what x is. Well, I don't know what x is. X is in the argument, so I can convert to an exponential. 2 to the 3rd power equals x. Remember, the whole point of logs is to get the exponent by itself, so 3 must have been the exponent. And now I can look at this and I go, oh, 2 to the 3rd, that's 8. So x is 8. If you didn't know that 2 to the 3rd was 8, you could type it in your calculator. 2 to the 3rd, and it'll say, oh, that's 8. Okay? So that's kind of the idea behind them, between exponential and log equations. Frequently, we'll turn our exponential equations into logs. Frequently, we'll turn our log equations into exponentials to help us solve. Okay? First part, we're going to look at some exponentials. All right? Now, one important idea to keep in mind. Let's say that I had 2 to the x equals 2 to the 5th. That is an exponential equation. Okay? X is in the exponent position. And if you're not sure what x is, I bet you can look at it and think, well, they have the same base. So if 2 to the 5th power has to be equal to 2 to the x, it must be that x and 5 are equal to each other. So that's the idea between what's happening on these first few examples, okay? If 7 to the 2x plus 3 has to equal 7 to the x plus 5, well, they have the same base. So the only way this is going to be a true statement is if 2x plus 3 equals x plus 5. And then I can just solve this equation like I've been doing, for years, okay? So I can get all the x's on one side. I can minus x on both sides. 2x minus x is x. X plus 3 is 5. Subtract 3 on both sides, and I'll get x is 2. We always want to check our answers. because sometimes as you're working with these exponential and logarithmic equations, particularly the log equations, sometimes you do everything right, but the answer you get doesn't work. So you always want to plug it back in to check. All right, so let's check 7 to the 2 times 2 plus 3, because I'm pretty sure x is 2. The left side works out to be some big old ginormous number. Let's try the right side. 7 raised to the 2 plus 5. Again, I'm plugging in 2 for x. The right side works out to be the same big old ginormous number. So 2 must have been the correct number to plug in for x. Okay. Similar example here on number 2. 4 to the 5x has to equal 8. Now, at first, it doesn't look like these are exponentials on both sides. Okay. So I'm going to show you 2 ways to work this one. I'm going to show you what the book says to do, and then I'm going to show you what I would do for this one. But I'll show you both ways. 4 to the 5x has to equal 8. Well, 4 and 8 are both powers of 2. 2 squared is 4, and 2 to the third is 8. So I'm going to replace 8 with 2 to the third, and I'm going to replace 4 with 2 squared. But that 5x is still an exponent on my 4, so the 5x is still an exponent on the 2. The 2 squared. Okay, if we raise a power to a power, we can multiply those exponents. So 2 times 5x is going to be 10x. And that has to equal 2 to the third, because the left and right have to be the same as each other. And now that we have 2 to the 10x equals 2 to the third, those have the same base. So 10x must be equal to 3. The exponents must be identical. And I can divide by 10, and I get that x is 3/10. Now, that is how your book tells you to solve that equation. And that's fine. That works. If you use the help features on your homework, that's going to tell you what to do. Step by step, you follow those directions. That's what you would do. You would get the right answer. But my opinion is that this is an exponential equation. Let's convert it to a log. Log base 4 of 8 equals 5x. Now, my x is on the main line. It's not in the exponent position anymore. It's on the main line. And if I divide both sides by 5, I will get x alone. So x equals log base 4 of 8, whatever that number is, divided by 5. Okay, so here's how I would type that in my calculator. If you're using an 84, okay, you can hit the fraction button, so I can hit alpha y equals and pick option 1 for the numerator denominator, okay? Alpha y equals, and then I picked option 1. And then in the numerator, I can hit math. I can arrow down to log base, and I can say, okay, it was log base 4 of 8, and my denominator of that was 5. So log base 4 of 8 divided by 5, and it's going to tell me that's 0.3. And hopefully you recognize that 0.3 and 3/10 are the same. If you didn't know that, you could hit math, convert to a fraction, enter, and it'll turn it into 3/10 for you. Okay? If you don't have an 84, you don't have the option of alpha y equals to get that fraction to pop up, and you don't have the log base feature. So in that case, you would use your change of base. You would have to say log 8 divided by log 4, and you're going to get this decimal, 1.5. And then that 1.5 number had to get divided by 5. So then I would just hit divided by 5, and it would take that last value I got, the 1.5, and divide by 5 and get my 0.3 that way. Okay? So either way is fine to type it in your calculator. My opinion is that this method is faster than this one, but they both work. On your homework, if you use the help features, it's going to suggest this way on the right, that first way that I did it. I just think it's easier here. Okay? All right, third example. Again, this is an exponential. Believe it or not, 1/9 can be written as a power of 3. It can be written as 3 to the negative 2. Okay, so if you rewrite this as 3 to the negative 2, both sides will have a base of 3. You'll be able to set the exponents equal to each other. 5x plus 3 equals negative 2 and solve. My opinion is that it's easier to convert exponentials to logs. So log base 3 of 1/9 equals 5x plus 13. Okay. Let's see if log base 3 of 1/9 is a nice, neat, pretty number. It will be. It's going to be -2 because 3 to the -2 will give you the 1/9. Okay? So if you are using an 84, you'll go to Math, arrow down to log base. Log base 3 of 1/9 is -2. If you are using an 83 calculator, you would say log of 1/9 divided by log of 3, and it'll tell you that's -2. So this left-hand side is -2. -2 equals 5x plus 13, and then I can continue solving that equation for x like I've always done. So I can minus 13 on both sides. -2 and -13 is -15. -15 is 5x. Divide both sides by 5. -15 divided by 5 is -3. So x is -3. Again, for a check, plug it in. So 3 raised to the 5 times -3 plus 13. And the left side is worth 0.111, that's 1/9. And the right side, 1 divided by 9, is that same value. So I know that -3 is the right number to plug in for x. Okay. Again, another exponential. Believe it or not, this 125 is 5 to the 3rd power. So you could, write them as exponentials, set the exponents equal to each other. Personally, I think it's better to convert to a log. Log base 5 of 125 equals 3x minus 1. Log base 5 of 125 works out nice and neat. Okay, it's going to be 3. Log 125 divided by log 5, I get 3. So 3 equals 3x minus 1, and I keep solving for x. So I can add 1 to both sides. 4 equals 3x, divide by 3, 4 thirds is what x is going to be. And if you check it, 5 raised to the 3 times 4 thirds minus 1. I put 4 thirds in for x. I type that left side of the equation in, and it says that equals 125. So I know that my 4 thirds was correct. On number 5 here, 1/4 equals 8 to the x. Notice they put the exponent on the right side. Typically we see it on the left. So if you want to rewrite it as 8x equals 8 to the x equals 1/4, you can. But you could just convert straight to a log. Log base 8 of 1/4 equals x. And if you don't know what this is, you probably don't, you can type it in your calculator. Okay? If you're using an 84, you can go to log base. If you're using an 83, you would type log 1/4 divided by log 8. And I'll be honest, I have an 84, and sometimes I still think it's faster to use change of base, so I don't have to scroll through all the way down to log base. I can just do log 1/4 divided by log 8. Okay? Now, that is an ugly decimal, but it's going to be -2/3, but if you want to have the calculator convert it into a fraction for you, remember the math button. Option 1 is convert to a fraction, and it's saying, you want me to take that last answer and make it a fraction? And you say yes by pressing enter. So our answer for x is -2/3. If you want to check, you can say 8 raised to the -2/3, and it'll tell you that it's 0.25. 0.25 is 1/4. Now, we don't have to worry about 6. We'll be okay with those. But that one, you don't have an option. You would have to get them as the same base. And 4 is 2 to the 2nd, 8 is 2 to the 3rd, and then adjust your exponents from there. Okay? All right. This next group is a little bit fancier. Okay? I don't have this option like this method over here, getting them as the same base and setting the exponents equal to each other. Okay? This is our general approach when we're solving exponential equations. Step 1, isolate the exponential. So in number 8, that exponential has been isolated. 7 to the 2x is the exponential. It's on one side all by itself. On number 7, the exponential has not been isolated for us. The 8 is in the way. So if you have something over on the exponent side with it, you're going to have to get rid of that first. So my first step here is going to be add 8 on both sides so that I can get the exponential by itself. So 9 to the x equals 5 plus 8, which is 13. Okay? Now, here is where I deviate a little bit from what the book tells us. The book tells us once we get to this point that we need to take the log of both sides. In other words, you can do whatever you want when you solve an equation as long as you do the same thing to both sides. You can add 8 as long as you do it to both sides. You could divide by 3 as long as you do it to both sides. You could square it as long as you do it to both sides. So what they are saying is, hey, why don't you take the log of both sides? So log of 9 to the x equals log of 13. Okay, I did the same thing to both sides. I put log in front of both sides. And then they say, hey, remember that property that you had that said if you had an exponent, you could pull it down front? That product property? So x times log 9 equals log 13. And then all that I got to do to get this x by itself is divide both sides by log 9, because x is being multiplied by log 9. So to undo it, divide by log 9. So x will equal log 13 over log 9. This is the exact answer, okay? Your homework asks for both. Sometimes it asks for an exact answer, so you would type in log 13 over log 9, okay? Or log 13 over log 9 is something you can type in your calculator, and you'll get the decimal 1.1674 if I go to 4 decimals. Make sure you read carefully how many decimals they want. It looks like our notes say 4 decimals. Okay? So this one right here, the log 13 over log 9, is our exact answer. And the 1.1674 is our rounded answer. And the homework asks you for both. Now, this is fine. This is a totally legit way to work this problem. If you're working your homework and you click on the help features to give you an example problem or to show you a next step, this is how they're going to have you do it. And that's fine. My opinion is that I think it's a little less work and you get the same answer by taking a small change after the adding 8. So I still have to isolate both sides. Both the exponential, so I'm going to add 8 to both sides, and I get 9 to the x equals 13. Okay, and then I say, well, that's an exponential, and I don't know what x is, but I bet I could convert to a log. So instead of taking the log of both sides, I just say, you know what, let me convert this to a log. Log base 9 of 13 equals x. That right there is my exact answer. Okay? This form right here gives us the answer in change of base format. This way here gives it in our log base format that we've been working with up to this point. They mean the same. Okay? In fact, in my calculator, if I'm using an 84, I can go to Math, Log Base 9 of 13, and I get that exact same decimal. Now, if you can't type this in a calculator if you have an 83. If you have an 83, you would have to type log 13 divided by log 9. But you know that already. That was in our change of base property that we already learned. Okay? So, to me, either way is fine. I think it's faster in the blue ink that I did here. Once I got my exponential, I just converted to log, and that was my exact answer. My rounded answer is still the 1.674, okay? But if you use the help features with the book in your homework, they're going to tell you to take the log of both sides, and they're going to tell you that it's log 13 over log 9. Those mean the same thing, okay? And it takes it either way that you type it in for your homework, okay? All right, number 8. They've isolated the exponential. 7 to the 2x is our exponential. It's by itself. So my suggestion is convert to a log. Log base 7 of 3 equals 2x. Now we're not quite done because we don't have x by itself. So what I'll have to do at this point is divide both sides by 2 so that I can get x alone. So my exact answer would be log base 7 of 3 divided by 2. That's my exact. Your homework is going to ask for both. It's going to want an exact answer and a decimal approximation. So in your calculator, you can hit alpha y equals to get a fraction. And then you can hit math and arrow down to log base and say that it's log base 7 of 3 And then that whole thing gets divided by 2, and it will give you your decimal, 0.2823. If you are using an 83, you don't have that log base option and you don't have that fraction option. So you would need to type log 3 divided by log 7, and then hit divided by, so it takes that last answer, that 0.56 number, and divides by 2, and that's when you get the 0.2823. But you get the same decimal. If you hit the help features on the homework, then at this point right here, they would say take log of both sides. So log 7 to the 2x equals log 3. Exponent comes down front, so 2x log 7 equals log 3. We need to isolate x, so we need to divide by log 7 and by 2. So I can divide by those at the same time. So my x would be log 3 divided by 2 log 7. That would be my exact answer, but when you type this in a calculator, you get the same decimal approximation. Okay, and the Connect Math homework would take an exact answer written either way. Okay, so if it's okay with you, I'm going to continue on by converting to logs rather than writing log on both sides, just because it's less writing and it saves a little space. But notice that if you use the help features in your homework, they're going to coach you to do it this other way. And that's fine. You get the same answer. Okay, so number 9, 10 to the 7x equals 6. This is an exponential. The exponential part is by itself. So I'm going to say log base 10. Now keep in mind, if the base is 10, I don't have to write it. It just knows the base is 10. Of 6 equals 7x. I don't have to write that 10 if it's my base. All that's left to get x by itself is to divide by 7. So my exact answer is log 6 over 7. And if you type that in a decimal, I can hit log 6 divided by 7, and I get my decimal 0.1112 if I rounded to 4 decimals. Okay. Number 10, another exponential. Remember, our first step up here is to isolate the exponential, get the exponent part by itself. So e to the x is my exponential. First I'm going to have to get rid of the 8. So I'll minus 8 on both sides. 2e to the x equals 50, because 58 minus 8 is 50. I need to isolate the exponential. I've got to isolate the e to the x, so I've got to get rid of the 2. 2 is being multiplied by e to the x, so I'm going to divide by 2. E to the x equals 25. Okay. This is an exponential. I've isolated the exponential part, so I can convert it to a log. Log base e of 25 equals the exponent of x. But we want to run into one little problem. Remember, we don't ever write log base e. If we want to put log base e, we write ln instead. So I'm going to say ln of 25 equals x. This right here is my exact answer. And if I type ln 25 in my calculator, it will give me the decimal approximation of 3.2189. Okay. If you use their strategy, then once you get to this e to the x is 25, then they would say take the log of both sides. They would actually suggest, it doesn't matter if you do log or ln, they would probably say ln since this e is the base. So ln of e to the x equals ln 25. That exponent comes down, so x ln e equals ln 25. Well, ln of e is just 1, so x is ln 25. You get to the same spot. Okay, not sure why that 4 decimals there. Sorry about that. Okay, watch this one, slight twist in this one that we haven't seen so far. It's an exponential. The exponential is isolated, so we're ready to convert to a log. Log base 5 of 7 equals x minus 4. Now, log base 5 of 7 is a number. It's going to be an ugly number, but it's going to be a number. Okay? In fact, I can type log 7 divided by log 5. Or if you wanted to do log base, if you're using an 84, Log base 5 of 7 is a terrible, horrible decimal. Okay. Rather than write that down, because they're going to ask me for the exact answer as well as the decimal, I'm going to leave that there. Log base 5 of 7. But I've got to get x by itself, so I've got to get rid of the 4. So I'm going to add 4 to both sides. Now here's where we have to be careful. That 4 is not being added to 7. That 4 is not being added to 5. That 4 is being added to whatever log base 5 of 7 is. It's being added to this 1.2 number. But for my exact answer, I'm going to say 4 plus log base 5 of 7. That is my exact answer. Then I can type 4 plus log base 5 of 7, or watch this. Since I know it was that last decimal, that 1.2 number, I can arrow up, and I see how it's kind of highlighted, and I can press enter, and that will paste it so that I can get my decimal approximation of 5.2091. Okay? Now, in my exact form, notice that I put the 4 at the beginning instead of the end. If you put it at the end, if you say log base 5 of 7 plus 4, there's nothing wrong with that, but sometimes people will accidentally think that that 7 plus 4 should be added to make 11. And log base 5 of 11 is not the same as log base 5 of 7, and then the result gets added to 4. So if you're going to put the plus 4 at the end, you probably should put your 7 in parentheses to tell people that just the 7 is in the argument position, that the 4 is separate. I avoid that issue by putting the 4 at the beginning. Okay? And then this one here, number 12, we can go straight to log. So log base 2 of 7 equals x. That's your exact answer. Type it in your calculator to get your decimal approximation. Let's try a couple more of these. Some messy decimals here, but it's going to work out okay. We can just say log base 3 of 0.07 equals negative 0.02x. And then to get x by itself, we divide by negative 0.02. So your exact answer is log base 3 of 0.07 divided by negative 0.02. That's your exact answer. Okay? And then you could type that in your calculator to get the decimal approximation. Number 14, a little different. Notice that we do not have the exponential isolated. We have to do a little bit of work to get the exponent part by itself. So we're going to subtract 4. So 3 times e to the 2x equals 11 minus 4, which is 7. Still need to isolate the exponential, so I've got to get rid of the 3. 3 is being multiplied by that stuff, so I'm going to divide by it. E to the 2x equals 7/3. I'm going to leave that as 7/3. If I take 7 divided by 3 and I get that 2 point whatever and I round it off, I will lose accuracy. So I'm going to leave it as 7/3. Okay? Now I'm ready to isolate my exponent, okay? And I do that by converting to log. So log base e. But remember, if you're going to write log base e, that just means ln. ln of 7/3 equals 2x. And then to get x by itself, we divide by 2. So my exact answer is ln of 7/3 divided by 2. That's exact. Now your decimal approximation will be ln of 7/3 divided by 2. So 0.4236. Make sure you close the parentheses around that 7/3 before you hit divided by 2. That closed parentheses is closing your argument. It's telling you to do the ln of 7/3 first, and then the result gets divided by 2. So that's our decimal right there. Okay. These last couple of examples, I don't think we need to worry about those. I put those on there, and then I looked at our homework, and I don't think we have to get that advanced. So don't worry about those last two. And in the next video, we will look at some log equations.